today's topic will be basically the concept is equation of motion only. Okay. So let us start it. Okay. See, let us have a particle moving along a straight line with constant acceleration. Remember, all the equations will be valid only for acceleration is constant. First, you have to verify whether the acceleration is constant or not. If it is constant, then only it is going to be valid. Okay. So, say this is the straight line. I am saying at t equal to 0, say particle is at origin. Okay, x equal to 0, we can say. And let's the velocity, okay, that t equal to 0, the velocity is u, initial velocity, and it is at origin also. Okay. Say at some small time interval, the velocity change is say dv. Okay, there is a small change in velocity. Okay, dv. So obviously at that moment the acceleration will be what? Acceleration will be dv by dt only. Okay, so directly I can write that dv equal to a into dt. Okay, so dv again, dv means a small change at a particular small time interval. Okay, but I need a big change, no? From v u to v. Okay, total change. So I have to integrate it, nothing else. So if I integrate from u to v, so here I have to integrate from 0 to t, because at t equal to 0 the velocity was u, initial velocity. So that the thing. Okay, but remember here a is inside the integration, because a is a is now inside the integration, but I will take the integration outside, because why? Know that a is constant. So if it is constant, so it will be definitely coming out of the equation. Okay, so if I take the in take it out, okay, of the integration, so what will happen? Since a is constant, we can place it outside the integration. Huh? So a is out. So ultimately integration of dv is v. So if I put the limit v minus u, okay, and integration of dt is t. So if I put the limit t minus 0, so t minus 0 is t only. Okay, v minus u equal to at. So v equal to u plus at. So this is our first equation of motion. Okay, means what is u when t was 0? What is v when t is t? Okay, when time is t, and a is the acceleration. Okay, so it is a very important formula. We should definitely keep it in box. Okay, first equation of motion you can see, and remember it is a vector equation. Huh? It is a vector equation. So if I put the vector sign, means here v is velocity, not speed. What I say here, v is velocity, not speed. U is also velocity. A is acceleration. So we can put the vector sign. Okay. So this is called vector form. So it means if I want to write along x, so it will be Vx is equal Ux plus Axt. Means there is no relation with y. Okay. No connection with y. Independently, we can write the equation along x. Even we can write the equation along y also. Okay. Similarly, we can write along z also. Okay. This is vector equation. No? We can write in all the three axes. Again, see this part is same only. You do not require to copy. From this, we are going to continue. Okay. The situation is same only. I am going to derive the second equation. Okay. So what we get, the actually at some dt time interval, say the displacement covered is say ds. Okay. In the dt time interval, say that the displacement, but I need to calculate the total displacement covered. Okay. So how can you see? I know that v equal to u plus at. U is constant because it is initial velocity. But v is variable. V is variable. Means time velocity will be different. At different t, the velocity will be different. So it is a variable. So now what I do, in place of actually v, I am putting ds by dt now. in place of v, let me put ds by dt. Because we know that v equal to the rate of change of displacement. Again, I am saying it is displacement, not distance. Because v is velocity. So ds by dt is u plus at. So ds will be what? U into dt, at into dt. Simply, okay? U plus at into dt. And when the time was 0, the displacement was 0. And when the time is t, the displacement will be s. Okay? So let us just integrate it. So this integration of ds is s. Integration of u dt is ut only because u is constant. So integration of u dt, it is nothing but integration of u dt. Okay? U integration of dt, which is equal to ut only. So, and at dt, a t dt, and t dt is nothing but t to the power 1 dt. Already I have told you. So it will be t square by 2 only. So it means half a t square. So this is the second equation of motion, very important. Write along with me only, okay? So that we should not wait for much time. Okay, again it is a vector equation. Remember, it is again a vector equation. So here s is not distance, it is displacement. So in vector form, what I put s vector, okay, is equal to in ut, u is the vector, okay, t is scalar, and in half at square, a is the vector, okay. So if I write along x-axis, it means sx, displacement along x-axis, okay, sx equal to ux t. If we talk about the displacement along x, so velocity along y has no relation with it, okay, they are independent. Sx equal to uxt plus half xt square. So similarly, sy will be sy will be uit plus half ayt square. Or if it is going along z axis also, so it will be sz equal to, they are similar only, okay. If you understand one thing, other only automatically be understood, okay. It will be sz equal to uzt plus half azt square. This time I am going to calculate that one velocity as a function of that one displacement, okay. Remember, we know that acceleration equal to v dv ds also now, because actually acceleration equal to dv by dt. But this can be written as v dv ds also. A is equal. See, you are multiplying by ds and dividing also by ds. So dv by dt. Now you just interchange this position, okay? So it will be what? df dt and dv by ds. So that ds by dt is nothing but v only. dv by ds, okay? So that's just same thing I am writing here, okay? So it means what? V dv ds equal to ads, okay? Crisscross. So on the left side, I have only velocity, and the right side, I have only displacement. Again, I integrate it because a is constant, so it will come out of the integration. So v dv integration is v square by 2 only, okay? So v dv integration is v square by 2. Put the limit v and u. So first upper limit, then lower limit, okay? It is simply v square minus u square by 2, and integration of ds is s only. So I hope you don't have any trouble while solving it, okay? So it means v square minus u square equal to 2as, okay? This is the final expression. So this is the third equation of motion, okay? Again, this this is actually not a vector equation, okay? This is scalar equation because v square, na? So always I'll get the magnitude only, okay? So, but we can write it in vector form. That is different issue. So how can I write? You can check it. So it means v dot v equal to u dot u equal to 2a dot s. Okay. If somebody asks you, can you write the third equation in vector form? Because v dot v is v square, na, you know. A dot a is a square. B dot b square. C dot c square. The vector product, na, you know. So along x-axis, if I write this equation, so what I get? Vx square is equal ux square plus 2ax sx. Similarly, along y-axis also you can write vy square, uy square, 2ay sy. And similarly, along z-axis also you can write vz square equal to uz square plus 2az sz. Okay. So these are the three equation of motions. Okay. We are going to discuss displacement in nth second. If we discuss displacement in, say, 5 seconds, okay, and displacement in 4 seconds. So if I subtract displacement from displacement in 5 seconds minus displacement in 4 seconds, I'll get the displacement in 5th second. Okay, that is the basic logic actually. Okay. So say this is something displacement, it is at x equal to 0, and this is x-axis. Okay. So at t equal to 0, I am here at x equal to 0 only. Okay. I will start my journey, and my initial velocity is, say, u, and at t equal to n second, I move to this position. Okay. It means displacement made by me is this much in n second. Okay. Exactly that way, at 1 second less. Okay. At you can say that t minus n second. Okay. Sorry, t equal to n minus 1 second. So I'll move little bit less. Okay. This much distance. Okay. So the gap is nothing but the displacement in 1 second. Okay. The gap is nothing but the displacement is 1 second only. Okay. Which is nothing but the nth second. Okay. This is the displacement in the nth second. Okay. So that gap, we are going to derive a formula for it. Okay. So what is nth second? It is nothing but displacement in n second minus displacement in n minus 1 second. It means the formula is simple, ut plus half it square. In place of t, you have to put n. And in the second case, in place of t, you have to put n minus 1. Okay, nothing else. So in place of t, I am putting here, you see, un minus half an square. Okay, ut plus half it square only. And in the second case, I am putting un minus 1 plus half a n minus 1 square. Okay. Then, so I hope you don't have issue till now. Okay. Then it is simple calculation only. Okay. You just break it. You just break it. You are going to get u. If you take the u common, you can see here it is u into n, and here it is u into n minus 1. So if you take u common, you get n. This is the minus, so this is minus, and n minus 1. Then plus, if you take a by 2 common, a by 2 common. So here you can find n square. This is minus, so it is also minus. And here, if you take a by 2 common, you get n minus 1 whole square. Okay. This is simple calculation. I hope you understood up till now. If you have any issue, just let me know. Till now.
No, Roger.
Okay, nice. Then we just simplify it. You see, u n minus n, it will be 0 only. Okay. So it will be just u, okay? This part will be u only. And the second part, you can see, here also if you break it, you are going to get n square will get cancelled. Finally, you are going to get 2n minus 1 only, okay? So this is the final formula actually. This is the formula displacement in nth second, okay? U plus a upon 2, 2n minus 1. Again, it is a vector formula only, okay? Here S is the vector displacement, okay? Not distance. Displacement in nth. U is the vector, A is the vector, okay? And actually, in this formula, now one interesting point is there, okay? Whether you can answer or not, let me check it, okay? Say S equal to what? S equal to U plus A by 2, 2n minus 1, okay? This is the basically formula. But now you see, is the equation is dimensionally correct? Because you see, that part is displacement, okay? This part is displacement only. This is displacement. So unit is meter, but this part is velocity. So is it dimensionally correct? But according to dimensional analysis, all the three terms must have same dimension. Na? This term, and this term also must have the same dimension. Then only equation will be correct. But here it seems to be dimensionally wrong. Huh? So what do you think actually? How can we break the puzzle? S dimension is meter, but whether this dimension is meter or meter per second,
Meter per second.
but it must be meter, na? So how can you explain this paradox? It is like paradox. Actually, what happened, it is actually, you see, this is n equal to second, na? So this is also 1 in second only. Okay, this is n second, this is 1 second, okay? So you see, this is u into 1. If you multiply it, that is actually u into 1. Here actually 1 is there. Actually this n and this n got cancelled, but this one is still there. So it is actually u into 1 second actually. Here it is u into 1 second. U is meter per second and 1 is second. So second got cancelled. So meter will be left on here. Okay. As it is 1, so it is invisible now, which is not seen. So it means you can say that this part unit is not meter per second. This part unit is meter only. Because it is not exactly u, it is actually u into 1. But 1 is actually not written, okay? That is the thing.
Yes.
Understood? Understood or
Yes,
not?
sir. Then for that acceleration, that term also we should write as L, no,
Oh,
sir?
here also, here actually it will automatically be coming. Let me check it. U is equal to u plus a by 2, 2n minus 1, okay? So here actually it is a by 2, n square minus, if I break it, it is n square, minus 2ab means plus 2ab, 2n into 1, yes. Yes, remember 2n into 1, 2ab minus b square, okay? It is also dimensionally correct. See, actually this term is actually a by 2 into, remember that is 2 into n into 1, okay? Minus that is 1 square actually, okay? So it means this part is meter, this part is second square, and this is also not second actually, second into second square. Because 2n into 1, 1 second, n second, okay? So acceleration
Yes,
is
sir.
per second square, and that 2n is second square, it is also second square. Second square minus second square is second square only. So this is also dimensionally correct, okay? So please try to solve this question. Let us practice some question and then nothing else. A car is traveling on a straight highway at speed 22 meter per second. Okay, means initial speed is 22 meter per second. The driver applies brake and causes uniform retardation, means acceleration, which is negative. Okay, minus 1.5. Find a stopping time, means final velocity 0. So you need the time actually. So out of the 4 equations, which equation will be that one?
V is equal to U
So
minus.
that you have to check out. V equal to U plus AT, this is one equation. So I think final velocity is given, initial is given, acceleration is also given. So T can easily be calculated. Okay. This easy question, easy question. Out of the 4 actually, we need to choose that one only. Okay. So initial velocity is U equal to this much, A equal to this much, V equal to 0. Car stops now. So V equal to U plus AT. So 0 equal to 22.5 minus 1.5.
15 seconds.
Pardon? 15 seconds. Yes, yes, yes. An athlete starts from rest, means initial velocity is 0. It accelerates to a speed of 8.5, means final velocity is there, but acceleration is not there. In 1.5 seconds, means T is given. If the acceleration is constant, find its acceleration. Find its displacement during the acceleration period, total distance. Plot VT xt graph. Graph part, leave it. Okay, graph part, leave it for the time being.
So acceleration is 5.66 meter per second
Okay,
square.
let me check it. V equal to U plus 80, 8.5 is this one. Yes, yes. Go to the next.
6.3 meters. So
Okay, let your 6. Displacement equal to UT plus half AT square. So U is 0, half into this much, 6.38. Yes, yes, yes. See, ये breeze है बेटा. Okay, this is a breeze. An object enters the breeze with velocity U and goes out of the breeze with velocity V with constant acceleration. With constant acceleration. So what will be the velocity at the midpoint of the bridge? Please try it. Or you can take, say this is V1, this is V2, okay? It enters the bridge with V1, exit when it goes out of the bridge with V2. So what will be the speed at the midpoint? Try it, okay? Little bit interesting, okay? Then you see, as it is the midpoint, it means this part's length, if it is S, so this part's length also will be S only. So if I apply between A and B, I'll use this formula only. Okay, B square minus U square equal to 2S. So between A and B, V square minus V1 square equal to 2AS. This is equation number 1. So between B and C, say this point is C. Now between B and C, so V2 square minus V square equal to again 2AS only, because S is same and acceleration is also constant. So from 1 and 2 you can see 1 and 2 will give you V square minus V1 square must be equal to V2 square minus V square, because this part is same only, right hand side is same. So from that you can say 2V square equal to V2 square plus V1 square. So it means V square is equal V1 square plus V2 square by 2. So V equal to what? The speed at the midpoint. That is an interesting question.
So 5 root 26 meter per second.
Okay. Let us check it. Starting from 20, ending at 30, need the velocity at midpoint. We can directly use the formula also. Otherwise, you can derive it also. Okay. Okay, under root 650, is it?
Yes, sir. If we simplify, it's coming as 5.6.
Say, question is, a particle initial velocity is say 10 meter per second, okay? So this is the particle going with 10 meter per second, okay? Take it 30, take it 30. But now it is getting a retardation, okay? Maybe due to wind or something, okay? Experience a retardation which is minus 10 meter per second square, okay? Now question is, find the displacement in fourth second. Okay, please try it. Displacement in fourth second. You remember, not 4 second. It is fourth.
Yes, sir. Minus 5 meters, sir.
I also think so. I also think so, because you see, the particle will at this point its velocity will be 0. Then it will come back. Okay, I think that 4 second is the return journey only. So what I do actually, directly I apply the formula. Okay, what formula? Ascent wala formula. It is equal to u plus a by t 2n minus 1, and u is 30 plus minus 10 by 2, 2 into 4 minus 1. That is equal to 30 minus 5, 8 minus 7. So that is, yeah, we're correct. So that is minus 5 meter. So minus 5 means actually it is in the return journey, okay? Minus. This is plus. Because at this point, I think after 3 seconds, the velocity will be 0 actually. If I check it, v equal to u plus at. So v will be 0, u is 30, acceleration is 10, t. So t is 3 only, okay? So it means first second it is going this way, second second it is going this way, third second it is going this way. So fourth second it is coming back. Fifth second also it will be coming back, and in the sixth second it will get the same position only. Okay? It will be like this.
Yes, sir.